The next portion of our training leads us to data attributes of measurement that are important to know for analytical purposes. These attributes are nominal, ordinal, interval, and ratio. These attributes help us to gain a firmer understanding of data, help us to understand how we can interact with the data, and will give us a chance to expand our horizons for analytical purposes. Let's first expand upon qualitative data. Of the following, which do you think would fall under qualitative data? Nominal, ordinal, interval, or ratio? If you said nominal and ordinal, you are correct, and we will start with nominal data. Nominal data is data where you can distinguish between different values, but not necessarily order them. For example, laptop versus desktop, or basketball versus football. You might have a preference for using a laptop versus a desktop, or for basketball over football, but overall nominal data is data that has a unique category but not necessarily an order to place it in. There is no way to just statistically say football is better than basketball, as there isn't a standard ranking of which is best. Think of nominal data as categories or categorical. Ordinal data, well, you might be able to guess from the name ordinal, is ordered data, where a ranking does exist. Think of first, second, or third, or small, medium, large. Items or data points will be assigned according to a ranking. One thing to note with ordinal data is it is a fixed ranking with an indeterminate distance between values. For example, a large t-shirt can vary between companies, or first place between different sports can be determined in a different manner. Again, ordinal data is categorical, where data points are found in the categories. Now, let's take a look at quantitative data and start with interval data. Interval data is like ordinal data, but the distance between data points is uniform. One very important note is not every arithmetic operation can be performed on interval data, and this is because there is no absolute zero, which we will not go over in this training. One example of this is looking at temperatures. 40 degrees is not exactly double 20 degrees in magnitude. Another example, think of temperature as interval data. Let's say Monday it was 34 degrees, Tuesday 37, Wednesday 40, and Thursday 34. The average temperature is 36.25 degrees, but can you sum up the temperatures to give an overall temperature over those days? The answer is 145 degrees, and we know that doesn't make sense. As was stated, some arithmetic can be done, but not all. Ratio data, on the other hand, can have all arithmetic operations performed. Think of it as taking in all the other attributes, but now you can perform arithmetic functions against the data. For example, you see the price of 3 different goods your client purchased recently. With ratio data, you can sum up the 3 prices to get the total purchase price. You could do arithmetic functions to understand the data more. So far, we have covered 2 different data types, with a third, discrete, mixed in a little, continuous and categorical. We then discussed different measurement attributes of data. There seems to be one data metric we have left out: time. This will be the next type of data we will explore. Time is very critical to analytics, as it comes into play frequently and helps drive answers. How many times have you seen a line chart showing trend of some metric over time? How often have you been in a meeting that shows a chart or table that compares 2 or more time periods? Time as a data point or attribute comes into play often. Let's take a few minutes to take a look at different aspects of time that can help you in analytics. Time has the ability to take many forms: years, months, weeks, days, hours, minutes, seconds, and the list goes on. Not only are there specific time periods that can be analyzed, time can be a continuous metric like a countdown, or a study monitoring things over time versus a specified time period. One of the key areas where time plays an impact is on the back-end build of data architecture. As a data architect builds data and tables, the correct format of time will be imperative for front-end analysis. Another way time is used in analysis is in time series analysis. A time series analysis is one that monitors metrics or data at a certain time period or time intervals. These time periods or intervals are equally spaced apart. Time series analysis might be the most famous form of data analysis that uses time. To help us understand a time series analysis better, we will take a look at an example. Imagine you are heading up an experiment and trying to find a cure or vaccine for a virus that has hit a major metropolitan area. You gather historical data to see how quickly the incidence of reported viral infection has been rising. You start off by creating visualizations using different time periods, days, weeks, months, and show over time how quickly this virus has risen in the community. The organization you are helping has developed medication to attack the virus and wants to determine if the medication has a positive or negative impact on the virus and those who have been infected. A positive impact would be a decline in the incidence of the virus or lessening of symptoms, and a negative impact would be an increase or no nominal positive effect. As the head of the analysis, you determine that frequent time capture is important to this analysis. So you determine each patient will come in to check in every day at the same time. As each patient checks in, you will check temperature, symptoms, and ask a series of questions. As you gather the data, you are able to mark each response and symptom against a timestamp. This timestamp has enabled you to build visualizations using the data to understand the impact of the medication. Over time, you are able to determine if it has been successful. The power of a time series analysis cannot be overstated. The ability to capture things over time enables analyses across many different measurements and dimensions. As was stated earlier, how often are we looking at analyses that have a time dimension to them? The remainder of this module will focus on the why behind the concepts we have just discussed. We want to ensure you, the user, have a sound understanding of these principles so that you can walk away feeling confident in your new knowledge. To begin, we want to discuss the importance of these concepts as it relates to data architecture and back-end systems. For a lot of you, it might seem like this is not your area of expertise or field of work, but I assure you it is important for you to understand these concepts. This helps you in your work with data architects and those who build the data behind the scenes. You will know how to talk with them and instruct them to build what you need. This can help make the communication between you and the back-end employees clearer and easier. Back-end systems consist of how data is built and how data is accessed. Companies and organizations have different avenues of obtaining data, and the back-end is tasked with the responsibility of making sure those on the front end have readable and usable data. The key term here is usable. Remember our fun phrase from earlier, crap in, crap out? The back-end is key to ensuring we do not fall into this trap. If the back-end data is not clean and usable, then the value being derived on the front end might not matter. Think about that for a second. If you are building something on the front end, say a time series analysis, data visualizations for a presentation, or something else using back-end data, if the data on the back-end is incorrect or designed poorly, it might not matter how strong your analytical and statistical knowledge are. You might be producing junk analytics. Thinking of our concepts from earlier, data types and attributes, how do these pertain to back-end data systems? The answer is pretty straightforward. Those working on the back end need to understand these data types to ensure the data warehouses, tables, and so forth are designed in a way or accessible in a way so that those using the data for analysis can build proper analytical results and share that with the world. Pretty easy, right? Yes. Correct back-end setup of data is essential for analytics. So, once the data on the back-end is set up correctly, front-end users can use it to build analysis and visualizations. Let's now explore why people on the front end would want to know about these data types and attributes. First, front-end employees like business analysts and business users will need to understand data types to ensure the analysis uses data correctly. For example, your boss asks you to analyze sales trends over the past 12 months, looking for trend analysis and to compare against forecast. As you start to analyze, you know to pull data that fits what you are looking for. You know that you will want to pull categorical data, such as month, product, region. You also know you will need quantitative data, such as sales and expense. Pulling this data will allow you to do a trend analysis on the information. Let's ask the question. To do the 12-month analysis, would you put the data into a pie chart? I hope not. To do a trend analysis, a line chart would be more helpful to see trends over time. Could a pie chart be helpful here? Well, Maybe not on a 12-month analysis, but let's say you want to analyze which product contributes more to sales and which product is lagging behind. A pie chart can show composition for a given month. Understanding data is key for front-end analysis as it helps the front-end employee know what type of data they are working with and analyze the data correctly. One other key aspect of the front-end user understanding data has been mentioned before: communication between the front-end user and back-end team. Sometimes one of the big issues in data analysis is the back-end building data that the front-end didn't request, or the front-end not being clear on what is desired and getting frustrated with the back-end teams. The reality is, usually neither side should be held at fault for errors or issues like these. Lack of understanding and communication usually plays a part. What is needed is a front-end and back-end team that can communicate well together. To do this, both sides need to be trained in the language of data. When both sides are trained properly on data, it makes it easier to communicate between the teams and arrive at better analytics. The front-end user can describe the needs to create analysis, and the back-end user can feel comfortable talking about different data aspects. When this is achieved, teams can proceed forward with good analysis and provide actual value to their teams, organizations, and companies. Now, let's take a moment to review what you have learned in this module. We first walked you through a definition of what data is. Data is facts or information that can be used for reporting, calculations, planning, or analysis. We also learned why it is important to learn and understand what data is. We then took a walk down data types and attributes lane. The data types that we covered are continuous, categorical, and discrete. The 4 attributes we discussed are nominal, ordinal, interval, and ratio. Each of these types and attributes of data helps the back-end and front-end users of the data to perform proper analytics. Another aspect of data that was covered was time. Time represents a unique data aspect for analysis. Time can come in different types of data, such as continuous or categorical. We also discussed time series analysis and went over an experiment to look at time in data. Finally, we brought it all together by discussing why it matters for the back-end and front-end employees. To finish, we want to direct you to different learning modules within the Qlik Continuous Classroom that will help you along your path to using data correctly. Visualizations represent a key element and principle of data. We have covered data itself and its importance to analytics. The Qlik Continuous Classroom offers more technical skill-based training on data and visualization in the different learning pathways: business analyst, business user, data architect. These trainings, combined with the analytics trainings, can further your data skills and help you with your overall analytical journey. We hope you will utilize all these modules to enhance your skills.
This represents the end of the video experience associated with this learning module. Please close this browser window, return to the course, and complete the remaining elements.